This is sideband, and this is NomadNet. I can send a message from sideband to NomadNet like this, and I can send a message from NomadNet to sideband like this. You can even view pages like this personal one, or this forum. Offline communication networks are often hard to establish, and previously, if you wanted to set up anything larger than a small-scale community mesh network, you used to be basically out of luck, let alone if you wanted to do so on any kind of budget. Luckily, there's a fantastic project that does exactly that. It's called Reticulum, and it's the most elegant solution for true global-scale peer-to-peer mesh networking I've seen. Reticulum has potential to become a truly offline replacement for the internet, working over almost every networking medium, including LoRa and packet radio. It's still in beta development, but already works astonishingly well. It's a full network stack down to the physical layer, everything is end-to-end encrypted per packet, incredibly efficient, and ingeniously simple. It enables self-organizing, unmanaged networks, scaling from a small community to a global scale at relatively low cost. Reticulum is a network stack that can be used to build any number of networks that can freely interconnect, and cannot be killed, surveilled, or censored. Reticulum does not require you to store other people's data in some kind of distributed file system or data store. It is exclusively a network stack. There is no reliance on any kind of cryptocurrency or blockchain, and it is incredibly lightweight, supporting very high latency and extremely low bandwidth mediums, as well as much faster connections. Before I show you how to get set up, we must first answer an important question. Exactly how does Reticulum work, and what makes it so special? Let's start with establishing some basic terminology. Destinations replace the concept of endpoints that IP and similar protocols use. All you need to know right now is that Reticulum destinations allow programs to receive data and are essentially arbitrary when compared to IP addresses. A single physical device can host multiple different destinations. There are a few types of destination. Single destinations allow for basic packet transmission using asymmetric public key encryption. Link destinations are abstract channels to single destinations, formed by establishing faster symmetric encryption and a set path for more efficient data transfer. Plain destinations are for broadcast traffic that needs to be public and not encrypted. Plain data is never transmitted over multiple hops in the network because routing requires encryption to verify paths. Group destinations are symmetrically encrypted packets to multiple destinations, which are not yet transported over multiple hops, though this is planned future functionality. Destinations do not know anything about the network beyond their immediate neighbors. They can move around a network at will and can even move to completely separate networks and still become reachable. To become reachable, a destination simply needs to send an announce to any network it is a part of. Announces are special signed packets that contain the destination's address, public key, and some other information needed to establish end-to-end connectivity with said destination. They are propagated throughout a network by transport nodes and allow Reticulum to form multi-hop connections between destinations. A transport node is a destination that is set to route data via a single configuration option. Not all destinations route traffic because this requires exponentially increasing bandwidth and decreased reliability in larger networks, just to support transport nodes that will never route anything. Reticulum can technically work without transport nodes, but only directly connected destinations will be able to communicate without them. A peer is just a standard destination that does not route any data, only sends and receives. Transport nodes can route traffic but are otherwise identical to normal peers. An interface is a connection over any medium between two or more destinations. And finally, identities represent any kind of verifiable identity of a person, machine control interface, or sensor. Identities are used to create multiple destinations cryptographically linked to that identity. Transport nodes forward data to a destination through a route determined by announces, which essentially tell every transport node the most efficient next hop for data sent to a specific destination. Destinations do not store any kind of map of the network, as that would be incredibly inefficient. When an announce for a destination is sent by a peer, it will be automatically recorded and forwarded by any transport node, subject to some specific rules defined in the Reticulum manual that I will simplify. If the exact announce has not been previously received, the transport node the announce was received from and how many hops it has already taken is recorded. Then the announce is queued to be retransmitted on all interfaces when certain requirements are met. Interfaces prioritize setting announces for destinations that are closest in terms of hops, thus prioritizing reachability and connectivity of local destinations. The keys and path to a destination can be requested from any connected transport node if a destination does not already have an announce from the destination it is trying to reach. There are more specifics about the routing, connection, and encryption processes in the Reticulum manual, but this should help you form a reasonable understanding of the concepts behind Reticulum's incredibly efficient routing strategy that allows transport nodes to directly pass data to a destination without needing to know the network's topology. That being said, you might still want to know what connections Reticulum can work over. The answer is basically anything, though there are some limits. The reference implementation of Reticulum currently supports connections over Ethernet, Wi-Fi, KISS mode packet radio, or serial connections, as well as TCP, UDP, and I2P. LoRa is also supported via R-Node, a digital radio transceiver program designed for things like Reticulum, supporting many common LoRa boards. Of course, that doesn't mean Reticulum only supports these interfaces. Currently, any connections faster than 5 bits per second that can send packets 500 bytes or larger are supported. So that means basically anything you can imagine, as long as the work is put in to support it. There is even a very easily utilized generic pipe interface that can use any external program as an interface, so you can add new devices without even touching Reticulum code. As long as 2 or more devices are somehow connected together, either directly or through devices with a transport node running, they can form a network. Remember that because of announces, Reticulum is self-organizing and can form a network over any and all of these interfaces simultaneously. Once the interfaces are set up and the necessary destinations are set to be transports, you're basically done with any network configuration. So that's great, but what's the point of a network stack that nothing makes use of yet? This is why the Reticulum creators made LXMF, a Reticulum native messaging protocol that allows for standard long and short-form messaging functionality, communication between network devices, paper messages, and offline reception of messages. Offline messaging is facilitated by LXMF propagation nodes, which store and forward messages to peers that are not directly reachable when a message is sent. LXMF propagation nodes can also provide infrastructure for distributed bulletin, news, or discussion boards. Propagation nodes will, by default, peer with each other and synchronize messages over time, automatically creating an encrypted, distributed message store. Users can retrieve their messages from any available propagation node. Propagation nodes are not required for LXMF to work. They simply serve to add optional functionality that many users will find helpful. It is very important to remember that LXMF's propagation nodes are not the same as the transport nodes that provide Reticulum's core routing functionality. Another project you may be familiar with is Meshtastic. It is often compared to Reticulum, even though they are quite different internally. Unlike Reticulum, Meshtastic works almost exclusively over LoRa and relies on flood routing. Flood routing gets exponentially less efficient for each node that is added, so their current limit is around 32 nodes and likely won't increase by much anytime soon. Meshtastic's stack can run entirely on a microcontroller, while our node currently requires a separate device like a Raspberry Pi Zero to handle routing. However, this might not be the case soon, as a port of Reticulum to C++ is currently in development. Meshtastic's encryption is optional, and radio share encryption keys network-wide, while Reticulum requires encryption and has forward secrecy, meaning that if a connection's key is compromised, no previous or future connections, even to that same destination, will be compromised. This means that the only real way to completely break Reticulum's encryption is to compromise the sender or recipient directly. Meshtastic is a great project despite its flaws, and I respect what they're doing, even though I still prefer Reticulum. Now that I've explained how Reticulum works, let's try it out. There are 3 major LXMF clients currently available: NomadNet, Sideband, and Reticulum MeshChat. NomadNet is a desktop terminal-based application with some features such as website-esque pages, while Sideband is a GUI app for both desktop and Android, which is somewhat easier to use and can send images and files in chats. Reticulum MeshChat is still being developed, but its goal is to be even easier to use than Sideband while keeping most of both Sideband and NomadNet's features. It also adds even more features like voice calling and voice messages, all still working over LoRa. To install any of these clients, follow the instructions on their GitHub pages. Once you've picked a client and installed it, you'll need to configure some interfaces so you can connect to a larger Reticulum network. In Sideband, this is done through the connectivity and hardware pages. With NomadNet, it is done through the config files and the hidden .nomad network and .reticulum folders in your home directory. And with Reticulum MeshChat, it is done through the interfaces page. The easiest way to get connected to other people and try out Reticulum is to join the testnet. You can find more info about that at the reticulum.network website. Remember that when changing any of these options, you must completely restart your client for changes to apply. Both NomadNet and Sideband have integrated guides explaining how to access and use their specific features, and I highly recommend reading them to better understand how to use each one. You might even discover some less obvious features like sideband situation tracking functionality that, if enabled, allows groups to be easily organized and located at a glance, and the repository page, which allows for the sideband app to be shared offline. For NomadNet specifically, make sure to pay attention to the keyboard shortcuts bar at the bottom of the screen. Each panel has different shortcuts that allow for a ton of functionality you might otherwise miss. So that's pretty much it for Reticulum's basics. To learn more, I highly recommend taking a look through the Reticulum Manual and Michael Farrager's Reticulum Primer, checking out the resources on unsigned.io, and chatting with the Reticulum community in the Discussions tab on GitHub and in the Matrix room.